Learning outcome 7 is about the speed of light. So how fast does light travel? And it's really fast. Right, 300 million meters every second. Right, or 3 times 10 to the power 8 if we're using our scientific form. Because it's such a special value, okay, it's kind of what we call a universal constant. It's fixed. It's always the same. It'll be the same today, tomorrow. It's the same whether you're in Australia, right, the UK, whether you're on Pluto, wherever you are in the universe. The speed of light through air or through space is the same. So it's given a special symbol. It's just the letter C, small c. And part of the reason it's so important is nothing else can go as fast as light. It's the fastest achievable speed in the universe. Now if we go into it in a wee bit more detail, nothing with mass can go as fast as light. Now light actually includes, if you go into a bit more detail, it includes other things like microwaves and infrared, what's called the electromagnetic spectrum. But all of them travel at the same speed and nothing goes faster. And any object with mass can't actually get as fast as light. So it's a kind of universal speed limit almost. And then we've got some calculations involving the speed of speed. And in physics, we write the speed, distance, time formula this way around. I know you've probably been taught it slightly different way, different symbols in maths. But we use a small d for distance, and usually that will be in meters. For our v, it stands for speed, believe it or not. It's from another word, velocity. And we write the units for that usually as meters per second, which we write as m/s. And our time, small t, should be in seconds. Now we do a couple of examples based on that. So a sprinter runs at 12 meters per second for 6 seconds. Calculate the distance travelled. And as usual, for all formulas in physics, we approach our calculations the same way. What information are we given in the question? We're given v, right? We're given the speed is 12 meters per second, and we're given that the time is 6 seconds. We're being asked the distance. So a formula, in this case, is the right way around. So it's just d equals vt. When we substitute our v and our t, then we can do the calculation. And we get that the distance is 72 meters. Example 2. We'll look at rearranging. Calculate the speed of a car which travels 100 meters in 3.8 seconds. So that's what we're given in the question. As usual, write down what you know. So we've got the distance and the time, and we've been asked v, which speed symbol is v, remember? So we do our usual in physics. We write out the formula as it's given in the formula sheet. Then we do our substitution. So I know that d is 100, so instead of writing d in the next line, I write 100. I don't know what V is, so leave it at V. Don't put a question mark in your formulas. It's easy to get confused about what you're actually working out. Now, I've done my substitution there, so that's an important step. That gets a mark in its own right. The formula gets a mark. And now I need to get to the right answer. Some of you, your math, you might be confident enough to go straight to it. But if you're not so sure, going through all the steps, well, first of all, the V was on the right-hand side, so I want to get it to the left. So all I do is just swap round both sides. I'm not changing anything there at all. But now I want to isolate V. I want a final answer that V is equal to something. I don't want to know what it is when it's multiplied by 3.8. So I want to cancel that multiplied by 3.8. And I cancel that out by dividing by 3.8. But whatever I do to one side of a formula, I've got to do to the other. So I have to divide both sides by 3.8. And then I get my calculator out, because you're always allowed to use a calculator in physics. And if I do 100 divided by 3.8, I would normally put this underneath, but I don't have space. Then I get my final answer here, which is 26.3 meters per second.